So I just wanted to make a little recap video showing what I did to this Heathkit model IM-4100 frequency counter. It had a few failures that were undiscovered when I made the last video. One of them being, when I opened the unit up, this yellow wire was tacked onto a solder point right there, and this wire was just dangling, and this terminal marked B had nothing connected to it. It was just a hole. And what I realized was that Heathkit wanted you to use these little connectors and solder the male part to the board and use the female part to terminate these two wires. What they are, this one, and these aren't the original colors, I replaced the wire. It was tiny stuff like that, orange one. This is the input. These wires come from this front panel switch and jack, input jack. So this is a signal input to the board. This is a ground connection, so that the input jack and that switch are connected directly to circuit ground. So I've got the displays reinstalled, the new ones, and I'll show you for a moment, and I'll show you another failure mode that it has. Okay, I'll plug this thing in. And you can see that the LED displays are all working properly, with one exception. And that exception is this overflow LED is locked on. It should not be on until the counter exceeds its max count. In a normal frequency counter mode, if you were in the megahertz position, well, if you were in the kilohertz position, that'd let you know you were measuring a signal higher in frequency than the unit was capable of displaying. So you flip it to the megahertz position. And by doing that, though, by toggling it back and forth, you can obtain a greater than the resolution that 5 digits would normally afford you. So while we're looking at this view, this stuff here is, it was double-sided sticky tape, and it's crumbling. That'll be replaced. When I troubleshoot this to find out what's causing that overflow LED to be locked on, I'll mention it. Hang on. Another thing that caught my eye that I don't like are these rectifier diodes right here. It's kind of hard to tell in this camera, but the circuit board is starting to discolor and turn brown, and it's not toasted yet, but it's heading there. And although this unit will never be left on for very long periods of time, I still can't accept that situation. The diodes are mounted flush to the board, and I don't know what Heathkit tells the builder to do, but those diodes need to be spaced above the board even a little bit. You know, 1/8 of an inch would be excellent. So I've got the filter cap on order, and this cap is okay, but I'm going to replace it. I thought that this cap was bad. It's not. I'm going to replace these 4, actually all 5 of those diodes with 1N4007s. I'm going to replace the cap and troubleshoot that LED, that overflow LED. And so when I've done all that, I'll edit these two together and post 73. Well, I got this Heathkit IM-4100 frequency counter, excuse me, working. I'm going to pause this. I got to clear my throat. Okay. I thought that the overrange LED was locked on, but I found out exactly what was going on. That LED in the far left-hand 2 digits should be blanked until those digits are needed. or until it goes into an overrange situation. I found the solder joints in this Heathkit were excellent. Having said that, the wire attachments to the board were miserable. Absolutely miserable. You're supposed to place the wire through the hole and then solder it from the bottom of the board, and they just laid it on the trace and gave it a grainy, gray, cold solder joint. Seemed like every time I moved the board, another wire popped off. So I got them all working, and so I replaced the 6,000 microfarad electrolytic filter cap with a 6,800 microfarad. I removed all of the original 4 bridge rectifier diodes, and I replaced them with new ones with 1N4007s, and I spaced them about 1/8 of an inch above the board so that it wouldn't continue to get cooked. Now I'm going to plug this in, and you'll see how that overrange LED came on, and the left-hand most 2 digits came on, then they go out. That's the normal operation. And the fault, the failure point, was IC14. It's a 7400 quad 2-input NAND gate chip, and that chip was bad, so I replaced it, and I'll demonstrate the operation of the left-handmost 2 digits and the overrange LED. Hang on. What you'll see I've done, I placed it into totalize mode, and I'm going to give it some input and make it start counting. I don't have a function generator to test this with, so while I let this count, I will mention that I did the oscillator calibration procedure using an external receiver and WWV. And so I calibrated that, and I believe it to be done. I'm going to pause this while it continues to count, and I'll bring you back when it's up into the 90,000s. I will add also that I began this little project as a why am I at a loss for words? I planned it to be a resurrection, but I found so much amiss that specifically the 7-segment display chips, and I looked at some of the 7490 decade counters, and boy, those pins are getting corroded. This generation of chips, some of them have a problem with corrosion on the pins. And if you were going to want to restore this and make it incredibly trustworthy and problem-free, you'd probably want to replace all the logic chips and eliminate the sockets, is what I do. Some of the ICs are okay, but all the 7490 decade counter chips have poor-looking pins, and they really should be replaced, but I'm not going to. I'm calling it quits. I'm calling it good. So you'll see when it hits 99,999, the overrange LED will illuminate to tell you that it has begun the count over again, and those left-hand 2 digits, watch, they will not blank. Now, there. The overrange LED is on to tell you that it went beyond the count 99,999. And it left the left-hand 2 digits lit to also let you know that fact. And yeah, so let me reset it. That's in the totalize mode. So anyway, it's always a lot of fun restoring or resurrecting Heathkits because you run into the solder issues. And I got lucky on this one, being that all the solder joints, now, on the printed circuit board were phenomenal. He just didn't, or she just didn't attach the wires correctly. My next restorations will be following my new format: a quick, brief overview, and then a slightly longer recap outlining what I did. 73. I hope you're well.